Okay, another mysterious parent question for us here, where they tell us about the offspring but not about the parents, and we have to work backwards. So Punnett squares can help with this, but it isn't just a direct Punnett square problem like we're used to, where we start with parents and then work out the kids. Let's see what we can do with it. For Mexican hairless dogs, first of all, legend, so we got to get this stuff organized, figure out what our letters are going to be. Hairless condition is dominant to hairy, so capital H shall mean hairless. That's the dominant, they said. And the recessive condition is actually having hair. And so there are three different genotypes that a dog could have. Big H would be hairless. Big H, little h is also hairless. And little h is the hairy version. Okay, so from all that, they say a litter of 8 puppies is found, 6 are hairless, and 2 are hairy. So we know nothing about the parents. Here's dad. Here's mom. The boxes are empty to represent my empty brain that knows nothing about them. And for the puppies, they're saying we got some hairless ones. Well, hairless is also maddeningly vague. That's big H, don't know. It's definitely a big H for start, and then this second letter could be another big H or a little h. Either way, they'd be hairless. But here's the good part. 2 of them are hairy, meaning they're little h. And from that, we can actually get a fair bit. What can you tell me about the parents? Maybe hit pause and think about this for a second, and when you come back, I'll spill the beans. Okay, so if a puppy down here has a little h, that means one of these came from each of its parents. So this puppy says, Dad gave me one of my little H chromosomes, and Mom gave me the other one. That means each of the parents must have had a little h. That's the only way you can have a double recessive offspring like this. So that's good. This one filled in 2 blanks for us. The other thing is, if some of the offspring have the hairless condition, have a big H, that means at least one of the parents must. So I don't know which parent this is, if this is the mom or the dad, and I don't care. I'm just going to say one of the parents absolutely has big H. And for this other parent, we have this blank. I don't know what to say about this. But that's still pretty good. We've got 3 out of the 4. Maybe we can try some guess and check now. What we've gotten from this is that there's 2 things that could be happening. This first parent is big H, little h, and they could be crossing with, this could also be big H, little h. Or this parent could be what they are, heterozygous, and this second parent could be little h, little h. We're down to only 2 possibilities, and that's pretty good. That means we could knock off 2 Punnett squares and see which one of these works, which one of them gives a ratio of like, let's see, 6 out of 8 is 75%, 2 out of 8 is 25%. We'll see which one of these gives a 75-25 breakdown of offspring. Do you know which one it's going to be? We've seen 75-25 a couple of times, so if you have a fairly good memory, you might already know what's going to happen. If not, you're about to see it happen again. For this, here I'll do the hetero, so big H, little h, cross big H, little h. And the other possibility over here is big H, cross little. Let's see what we get. Okay, so for here, the parents' genotypes are there. The gametes they can pass on are either the big or little from one parent, big or little from the other parent. That gives us big. Here we get big with little. Here we get the little h and the big H. And here we get little h. I'm starting to go through these a little faster because we've seen it a few times. If you're still feeling wobbly about this, get a hold of the tutoring service or the instructor, and they'll be happy to take you through it again, cover any questions you might have. what does this give us? We get anything with big H is going to be hairless, so I'm going to write bald because it's quicker than writing hairless. Bald, bald, and this one is hairy. This is 75% bald and 25% hairy. This is looking good, actually. This is a great match for what we have, the 6-2. Does this one work also? Big H, little h from the one parent. This parent can only contribute little h's, so I'm going to do that and just lose this second column. We don't need it. Here we get big H, and little h, which ends up being 50% hairless, 50% hairy. So what is the genotype of the parents? Well, it could be this. These could be having some weird luck just because these are 50% probabilities doesn't mean you're guaranteed to get half and half. Just like human families don't have exactly half boys and half girls, there's some variation in there because of luck. But this is awful nice. This predicts 75% hairless and 25% hairy, and that's exactly what came out here. So this is most likely, and this one I'm going to say is possible, but definitely not the best bet. This one is the best bet.